Season 2 of the Code Like an Architect series, Abstraction in Action.
What is abstraction? As we have already learned in the big picture, abstraction is the act of hiding the underlying details, right? But here's the catch. You can technically hide anything behind an interface and call it an abstraction. Take this example. Is this an abstraction? Yes, technically it is, because we are hiding some details. But the real question is, how good is this abstraction? Whether it truly delivers the benefits of abstraction depends entirely on how well you design it. And that's where the abstraction design principle comes in. It says design for the user. It's a quite common experience with developers who come to know about the importance of abstraction and interfaces for the first time, and then they decide to use it. But still, they don't notice any big difference or get the practical benefit. For example, they use interfaces but still find themselves making changes every time something new comes up. They often feel that they are using interfaces just for the sake of using it, or just because it's considered a best practice. But again, they don't witness any big difference. Most of the time, this happens because they don't design abstractions correctly. This happens because they don't truly understand how to design abstractions. So, in this video, we will learn the key principle to design abstraction. Design for user. I'll explain this principle using two simple but very relevant examples. After watching this video, you will understand how we can design abstractions properly and actually get the benefits. And on the other hand, you will also see what happens when we don't design them correctly. And as a result, we lose all those benefits. Example 1. Let's say we need to build the functionality to upload images in an application. We already have a dedicated microservice that handles image storage. The service works on HTTP POST. So, whenever the web server receives a request to save an image, it simply sends that image to the microservice using an HTTP POST call, and the service stores it. Now, let's create an interface for this. Here is what it looks like, and here is how we are using it. The file gets uploaded to the web server. We read the stream. This method converts the stream into HTTP content, and then we call our interface with the URL and the content. So, that's how we implemented image uploading in our system. Now imagine it has been running in production for a while, and by this point, we are uploading images from several different places in the codebase. Do you think this is a good interface? Do you notice any problems? One of the main benefits of using interfaces is that you can switch to a different implementation whenever needed, without having to make changes everywhere in the code. That's the power of abstraction. Let's see how it happens. Suppose we are using implementation 1 through an interface. As you can see, we are not interacting directly with implementation 1. Instead, we are interacting through the interface. We have registered implementation 1 against the interface in the DI container. Later, we build implementation 2 and register implementation 2 against the same interface. Since the entire code base interacts through the interface, we can now switch to the new implementation seamlessly without touching every single file in the code base. Now let's see, can we actually do this with our interface or not? Suppose after some time, we decide we don't want to use this microservice anymore. Instead, we want to move to a cloud service. But this cloud service doesn't work over HTTP. It comes with its own built-in libraries. So the question is, can we still switch seamlessly to this new cloud-based implementation like this or not? Can we just register the cloud implementation against the interface and expect everything to work without changing anything else in the code? Unfortunately, no. If the cloud service also worked over HTTP POST, we could have simply changed the URL and everything would have worked fine. But here, the cloud service doesn't use HTTP. It has its own dedicated libraries we need to work with. So in this case, we cannot seamlessly move to the cloud service just by switching to a new implementation, because this new implementation doesn't fit with the existing interface. The interface is simply not compatible with anything that doesn't work on HTTP. So we will have to make changes everywhere. And that's a problem. We are using abstraction, we are using interfaces, and still we are not getting the benefits. And do you know what's an even bigger problem? Situations like these make many developers think that concepts like abstraction are just bookish and theoretical, and they don't really deliver any practical benefits. And honestly, that feeling makes sense. We are doing abstraction and still we are not getting the benefits. So what's the point of putting in all the time and effort, right? But the truth is, it's not abstraction that's the problem. It happened because we didn't design the interface correctly. If you think carefully, our interface was never designed with the user in mind. Instead, it was designed with the implementation in mind. It's tightly coupled with the HTTP implementation. Think about it. It's way too focused on the fact that we are using HTTP post to save images, right? That's an implementation detail. It's not focusing on the user. And that's exactly why we couldn't switch seamlessly when the implementation changed. So now we will see how we could have designed our interface correctly. And if we had done that, we would have definitely gained the practical benefits of abstraction as well. Let's begin. Let's design it for the user now. We need to save images, right? And this class is the user that needs to do it. So this is the user. Now, design for this class. Forget for a moment that we have some microservice that saves images and works over HTTP. Suppose we don't know that yet. Just focus on the user for a moment. All we know is this class needs to upload a file. We know nothing else. Design an interface for this class. How should it look? What should this class say? It will say, this is my file, save it. That's it. And that's how we say this in the code. A stream is a variable that gives us access to a file's content. And file name is simply the name of the file. Something like this. Or we can further improve this by using a file info model, like this. Now see the difference. This one is designed for the user's need. Save this file with this name and give me an identifier. It's designed from the user's perspective, not from the implementations. It says nothing about HTTP post. It says nothing about microservice. And because it doesn't mention or know anything about those implementation details, it never gets coupled with them. So when those details change, this code remains intact. Whereas the previous version was deeply aware and hence coupled to those implementation details. So when the implementation changed, the interface got impacted, requiring changes everywhere. Now let's handle the same change that we tried earlier, but this time with our new design. Suppose we now want to move to a cloud service that works with its own dedicated libraries. So we will simply write another implementation of the same interface, like this. Since this interface is designed for user, it's compatible with the new implementation as well. We will register it in DI. The same interface will continue to work everywhere in the code without needing a single change. Behind the scenes, the internal implementation has now moved from the microservice to the cloud, and we didn't face any problem at all. The user code still just says, save this file, but underneath, it's now saved on the cloud instead of the microservice. The user is completely unaware and fully decoupled from all those details. This is the abstraction design principle. Design for user. Now let's see another example. Let's review this design that we saw in the beginning. Is this a good abstraction design? Before I answer this, it's important to understand that abstractions are not designed randomly. We don't just come up with anything and call it an abstraction. Abstraction is not just about using interfaces. Many developers, when they start using interfaces, they think that they are using abstraction. They often just mirror all the methods from a class into an interface without any thoughtful design. No, it's important to understand that abstraction is not just about using an interface. We can't just throw anything into an interface and call it an abstraction and then expect to get all the benefits out of it. It's not a random process. No, we have a clear and definite criteria for designing abstraction. And that criteria says design for the user. Using this criteria, we can design a good abstraction and actually experience the benefits. And using the same criteria, we can also evaluate any existing abstraction design. So with this in mind, let's evaluate this abstraction. Is this a good abstraction? The answer is it can be both. It can be a good design or a bad one. We can't decide this in isolation just by looking at the interface and the implementation. According to the abstraction design principle, an interface should be designed for the user. So to decide whether it's a good design or a bad one, we first need to find out, is it designed for the user or not? And for that, we will need to identify who the target user of this abstraction actually is. So this is a logging interface. We want to use this for typical logging purposes, just like we do it in most applications. So for that purpose, this may not be a good design. Think carefully. As a user of a logging interface, we want to log a message. We also want to specify the destination like file, database, or something else. But we don't want to specify the destination every time we log. But this interface forces us to specify the destination on every call. Think again. Let's analyze what we want as a user of a logging interface. We need to log messages, right? We also need to specify a log level with each message, like error, warning, info, and so on. We need to choose and configure the destination, a file, a database, or something else. We may also need some additional configurations like setting a minimum log level and so on. Now, if we focus on the user's needs, we will reach a simple conclusion. We need two interfaces. One to write logs, the one we use every time we need to log something, and another to configure logging, usually a one-time setup. So, this is what the first interface might look like. We will use it every time we need to log something from anywhere in the app. And this is what the second interface might look like. We use it to set the destination and other logging settings only once, typically at application startup. And since this is a one-time configuration, a JSON interface makes perfect sense. There could be a C# interface as well if you need to set things up dynamically. By the way, it's important to understand that abstraction is not limited to classes or interfaces. As we already saw in the previous video, abstraction is everywhere. So that's how the abstraction should look when we design for the user. And this one, that's not designed for the user. Why? Because it asks for the destination every time we log something. As a user, we do want to specify the destination, but not at the time of logging. That's a subtle difference, but it's enough to take away all the benefits of abstractions if not analyzed correctly. Now look closely and compare these two abstractions side by side. This one is designed with the user in mind. We have carefully considered how the user would actually want to work with it. That's what makes it a good design. Now look at this one. That's not designed for the user. Instead, it's closer to the implementation than to the user. All we have done here is just created methods based on the very first thought that came to mind. We are not doing any analysis. We are not thinking about the user's need or any design intent. We are simply mirroring the implementation, just putting some methods into an interface. And because we have missed the key idea behind designing abstractions, which says design for the user, this design will not deliver the real benefits of abstraction. Let's see. Suppose we are using this design to log to a file from everywhere in the application, like this. Now what happens if we later want to log to a database? We would have to make changes everywhere in the code. Why? Because the abstraction was never designed for the user in the first place. We were unnecessarily asking for the destination every time we logged something, creating tight coupling. So when the destination changes, the entire code base has to change too, giving away all the benefits of abstraction. Now compare this with a design that's thoughtfully created for the user. We are still adding logs from everywhere in the application. But now, when we want to switch the destination from file to a database, we will just update the one-time configuration, like this. And instantly, everything is redirected to the database with just one simple change. No modifications required anywhere else. The rest of the code keeps logging the same way as before, but behind the scenes, the destination has changed. That's the abstraction design principle. Design for the user. See how we rationally concluded that the first interface design wasn't right for our scenario, and how we logically arrived at this improved design by simply following the abstraction design principle. This gives you decision-making ability. It's important to understand that designing abstractions is not a random process. You can't just put anything into an interface and call it an abstraction, and then expect to get all the benefits, and later blame the concept of abstraction when things don't work out as expected. So that's the key takeaway. Design for the user, and then expect all the benefits of abstraction. And that's wisdom. That's what I try to deliver through this channel. Anyone can use interface and think that they are doing abstraction. But the real wisdom lies in understanding the abstraction design principle. Design for the user. And by the way, this isn't something new. It's something that Uncle Bob has already talked about in his books. And honestly, you will find this principle common across all disciplines, as we have already demonstrated in the 100 real life examples of abstraction. Actually, it's only some developers who are often unaware of this principle. So they either don't design abstractions at all, or when they do, they don't design for the user. I hope you found this video useful. If yes, let me know in the comments. And before you go, I'm leaving a question for you. We saw that this interface design wasn't appropriate in our scenario. My question is this always a bad design? Answer with yes or no in the comments and back it up with your reasoning. This was the abstraction design principle. That's the key principle, and it's more than enough to help you design great abstractions. If you follow this path, you will naturally keep improving as you design more and more abstractions. And once you start following this principle and design good abstractions, you will begin to experience the real benefits of abstraction. So, next in the season, we will talk about the benefits of abstraction, starting with one of the most important ones: reduced complexity. Keep watching.